Chapter 5, Part 2, Time Value of Money, Bond and Lease Payments, and Future Value. Now, there are 6 present value tables. The first 3 determine the present value of a future amount based on a specific interest rate. We have a present value of a single sum. An example would be, what is something going to be worth in today's dollars if we were going to receive it sometime in the future? Present value of annuity, what would be the present value of a stream of payments over a period of time? And present value of annuity due, the difference between the present value of annuity and present value of annuity due is, for present value of an annuity, the payment is made at the end of the first period. Present value of annuity due, the payment is made at the beginning of the period. So on September 30th, my corporation issued 8% stated rate bonds with a face value of $300 million. The bonds mature in 20 years. The market rate is 10%, and the interest is paid semi-annually. Now, here's the thing you now remember: whenever you're trying to figure out the present value of a bond, you have 2 things. You've got a future sum, a single sum that's going to be paid after a period of time, in this case 20 years, and also you have a stream of payments, which are the interest payments that are made semi-annually. So you have to figure out the present value of a single sum and the present value of an annuity when you're looking at bonds. So how do we determine the cash proceeds? Well, first we need the face of the bond. How much is going to be paid at the end of the period? In this case, it's $300 million. We also need the stated rate. How much is the cash payment? That's going to be the 8%. The effective rate. This rate is used to determine the factor from the value tables, the rate and the number of periods when we go to the factor table, and this is going to determine how much interest is actually being paid. So, the number of periods, we also need this to determine the factor N when we're going to those present value tables. So now what we're going to do is we're going to find the information we need. So again, we have the $300 million. We have 40 periods because it's semi-annually, so it's twice a year. We know that the stated rate is 4%, and we're going to use that to figure out what the semi-annual cash payments are. You always use the stated rate to determine that. And the effective rate is what we're going to use when we go to the table, the present value table. Also, it's going to be the rate we use to figure out interest expense. So now let's take a look at our table where we have 30 million. We need to figure out the present value of 300 million, and we need to know the present value of 40 payments with an effective rate of 5%. So we need to find 2 factors. So first, we're going to go to the present value table of a single sum for 40 periods. So we're going to go down to 40, which is N, and we're going to go across to 5%, which is paid semi-annually, and that's going to be our factor. That's what we're going to take times the $300 million. Then we're going to go to a present value of annuity because the interest is paid over time, which means it's paid at the end of the period. So we're going to go to this table. We're going to go down 40 periods. We're going to go across to 5%. And now we have our factor of 17,15909, which we're going to take times our semi-annual cash interest payments. So we now can determine the cash proceeds when we issued the bonds. So we're going to take 300 million times the present value factor, and we're going to take 12 million, which is the cash payment, times the present value of annuity, and that's going to give us the total cash proceeds, and now we can do our journal entry. So bonds payable is going to be the face of the bonds. That's $300 million. The cash is going to be $248,524,080, and the difference is going to be discount on bonds. Now, what is our first interest payment based on using the effective rate? Well, our cash is always going to be the same. It's going to be face of the bond times the stated rate divided by 2. Now, interest expense is going to change every single time because what it's going to be is the net book value of the bond times the effective rate divided by 2. And then you solve the discount on bonds as the difference. It's always a plug. Now let's take a look at lease payments. Now, March 31st, Southwest Gas leased equipment from a supplier and agreed to pay $200 million annually for 20 years, beginning March 31st. General accepted accounting periods require the liability be recorded for this lease agreement for the present value of the scheduled payments, and we're going to assume a 6% interest rate. So we know it's 20 years. Those are the number of payments because it's made once a year. We know that the interest rate is 6. And we know that this is annuity because we're paid annually and it's being paid at the end of the year. So we know what table we're going to go to. The present value of an annuity table. So we're going to go 20 periods and we're going to take our 6%, and that gives us the factor. So now what we're going to do is we're going to take our 20. The actual cash paid is $4 million, which is $200,000 times 20 year, but the present value of the payments is $2,293,984, and the interest expense over the 20 years is $1,706,016. So what's our journal? Right of use asset is $2293, and lease payable $2293,984. Now, what if, same example, if the first payment has been made when the lease is signed? Then we're going to use the present value of an annuity due. We're going to go to our present value of annuity due table, 20 years. We're going to get our factor. And now we can calculate. And now our interest is going to be $1,568,000. It's going to be less because we made a payment before any interest had accrued. And our journal would be right of use, lease payable. Now we have one last problem we're going to look at. What if Mike wants to accumulate $100 million to be used for his son's college education? He would like to have the amount available in 5 years. Assume that the funds will accumulate in a certificate of deposit paying 8% interest, compounded annually. Now, we have 3 choices. What amount do we have to deposit today that would be worth $100,000 in 5 years? What amount would we have to pay if we first paid at the end of each 5-year period to have $100,000? And what amount would we have to pay 5 equal payments if we started at the beginning of the year? Now, the first one we would use present value because we want to know the value today. So we're going to go to the present value table. We're going to be 5 years at 8%. We have our factor. And we're going to take that times 100,000. It tells us if we put money in the bank today, $68,058, at the end of 5 years, we'll have 100,000. Now, for the next problem, we want to know how much we need to pay in order to have 100,000. What payments would we have to make in the future? So in this case, we're going to use the future value table. And we're going to use the future value of an annuity table with n equals 5 and I equals 8. So 5 years, there's our factor. So what we're going to do is divide that into 100,000, and it tells us if at the end of each year we put at 5 years, we put in $17,045, the end of 5 years we'll have $100,000, assuming we get 8%. Now, what happens instead if we make our first payment at the beginning of the year? Well, we're going to have to go to the present value of an annuity due, future value of an annuity due table, because this is we're trying to figure out what the payment is going to be at the end of each period. So we find our factor, and what we're going to do is take that factor and divide it into 100,000. And if you notice, we have to pay less, and we would pay our first payment at the beginning of the period and then $15,783 at the beginning of each of the 5 years. That concludes this presentation. So remember, in this example, we would use the present value for the first one because we want to know what do we have to put in the bank today in order to have 100,000. In examples 2 and 3, we want to know how much do we have to put in the future, so in the end we end up with 100,000. In that case, we have to use future value tables of an annuity or an annuity due, depending on when the payment has to be made.